Embark on an extraordinary visual journey as we introduce you to 14 new images, freshly delivered by the renowned James Webb Space Telescope. These images are not just glimpses into the cosmos, but gateways to understanding our universe's grandeur and mysteries. Each capture presents a unique celestial spectacle, encapsulating the cosmic wonders that stretch across our incomprehensible universe. Fasten your seatbelts, for you're about to ride the waves of light that traveled across billions of years to meet the eye of the Webb and unveil these staggering cosmic marvels. Image number 1. The Dance of Creation in the Cosmos, Herbig-Haro, 4647. Unleashing energy beyond our wildest imagination, a pair of nascent stars enthrall us with their cosmic performance. The stage for this celestial drama is set within the universe's grand theater, captured in high-resolution near-infrared light by none other than NASA's James Webb Space Telescope. Our protagonists, christened Herbig-Haro 4647, are the spotlighted duo positioned at the heart of the red diffraction spikes. What might these diffraction spikes be? Think of them as starlight's brushstrokes, scattered in a pattern akin to a child's drawing of a star, radiating lines from a central point. Intriguing, isn't it? Delving deeper, the pair appear as an orange-white smudge, enveloped in a swirling ballet of gas and dust. This revolving disk not only forms a cosmic cradle, but also serves as the primary ingredient for star growth, continuously feeding and adding to their mass. Unraveling the mystery of Herbig-Haro 4647 reveals their youth, merely a few thousand years old, quite the cosmic infants compared to other celestial bodies. Wondering why this youthfulness is significant? It's because stars like our own sun require millions of years to reach their full formation. Analyzing juvenile stars like these provides astronomers with a blueprint of the sun's early life and the captivating process of star evolution. Captivatingly, the pair don 2 orange lobes, signatures of their past energy ejections. Their latest ejections trace a blue thread, interweaving with the angled diffraction spike overlaying the orange lobes. Sounds complicated? Let's simplify it. Think of the stars as cosmic artists, their ejections the brushstrokes, painting a complex celestial portrait across the sky. As these stars evolve, they consume the surrounding gas and dust from their cosmic cradle, much like a caterpillar feasting on leaves. However, there are times when they overindulge, much like us during holiday feasts. What happens then? The stars react, much like our stomachs would, expelling 2-sided jets along the opposite axis. This ejection acts as a pressure relief valve, calming the star's spin and reducing its mass. This cycle continues over thousands of years, controlling the amount of mass the stars accumulate. There's more to this astronomical tableau. Spot the semi-transparent blue cloud, a nebula filled with dense dust and gas. Webb's advanced near-infrared capabilities allow us to peer through the nebula's translucent veil, exposing much more of Herbig-Haro 4647 and unveiling distant stars and galaxies far beyond it. The nebula's periphery glows in a soft orange hue, forming a backward L shape on the right and bottom. This blue nebula plays a crucial role, acting as a cosmic mold that shapes the orange jets propelled by the central stars. As the star-driven material collides with the nebula, it takes on wider forms, a result of interaction with the nebula's resident molecules. This nebula interaction also lights up the star's ejections, creating a visual spectacle. Give it millions of years, and the infant stars of Herbig-Haro 4647 will reach their full form, leaving behind a scene cleared of their youthful antics. Now let's shift our gaze to the backdrop. An array of extremely distant galaxies speckle Webb's field of view, captured by its NIRCam, near-infrared camera. This snapshot is a composite of numerous exposures, each highlighting a galaxy or star. Blue objects crowned with diffraction spikes are stars, and their size often indicates their proximity. Spiral galaxies painted in hues of white and pink often appear larger, but are considerably farther. The tiniest red dots, revealing Webb's infrared expertise, are typically the most ancient and far-flung galaxies. To provide more context, the Herbig-Haro 4647 complex is situated in the Vela constellation, about 1470 light-years away. The image spans 7.3 arcman across, translating to approximately 3.1 light-years, placing the grandeur of this scene in perspective. The universe's theater is vast and profound, with new stars like Herbig-Haro 4647 performing an intriguing act of creation. As we journey through the cosmos with technology like the James Webb Space Telescope, we continue to uncover these enthralling performances, expanding our understanding and fueling our fascination for the wonders beyond our blue planet. Image 2. Observing the skies through the lens of the North Ecliptic Pole. Time domain field in the universe's silent but spectacular show, the James Webb Space Telescope, an advanced venture by NASA, delivers a grand performance. One of its recent and most fascinating exhibits presents a medium-deep wide-field snapshot of the universe, a splendid view of a region called the North Ecliptic Pole. This image, a captivating visual aid in a scholarly paper for the Astronomical Journal, is the fruition of the prime extragalactic areas for reionization and lensing science, PEARLS, Guaranteed Time Observations, GTO program. Wondering what medium-deep wide field means? Medium deep refers to the faintest, almost elusive celestial bodies that can be seen in this image. These are about 1 billion times dimmer than what our naked eyes can perceive, around 29th magnitude to be precise. As for wide field, it denotes the total observable area that will be mapped by the program, roughly equivalent to 1/12 the size of the full moon. The image, a breathtaking spectacle of the universe in its authentic colors, showcases galaxies far beyond our reach, many of which were invisible to the Hubble Space Telescope or even the most powerful ground-based telescopes. Alongside these far-off galaxies, the image also exhibits a variety of stars from our very own Milky Way. This engaging panorama is the result of merging 8 colors of near-infrared light captured by Webb's near-infrared camera, a NIRCam, supplemented with 3 shades of ultraviolet and visible light from Hubble. Moreover, the images obtained through NIRCam will be amalgamated with spectra acquired using Webb's near-infrared imager and slitless spectrograph, NIRIS. This symbiosis will aid scientists in their search for faint objects with spectral emission lines, spectral fingerprints, if you will, which can be used to estimate their distances with improved accuracy. Members of the PEARLS team, the creative minds behind this image, share their unique experiences and initial reactions while working on this field. The collective sentiment echoes a profound appreciation for the unprecedented detail and resolution that Webb's images offer, rendering visible galaxies and celestial bodies that were previously beyond human reach. Rogier Windhorst, Regents Professor at Arizona State University, ASU, and the Principal Investigator for PEARLS, confesses that Webb's images exceeded his wildest dreams. His colleagues Rolf Janssen, a research scientist at ASU, and a PEARLS co-investigator, Jake Summers, a research assistant at ASU, Rosalia O'Brien, a graduate research assistant at ASU, and Seth Cohen, a research scientist at ASU and a PEARLS co-investigator, all share this sentiment. Anton Kokomor, a research astronomer at STSCI, who assembled the PEARLS images into expansive mosaics, shares his colleagues' enthusiasm. He adds that monitoring this field throughout Webb's mission will enable the discovery of time-variable objects, such as distant exploding supernovae or bright accretion gas around black holes in active galaxies. These objects, with their unpredictable patterns, should now be observable at greater distances than ever before. Rogier, concluding the team's shared insights, highlights that the unique design of this field ensures that it can be observed with Webb 365 days a year. As a result, its time domain legacy, the area covered and the depth reached, can only improve with time. Just to frame this in context, the North Ecliptic Pole, as part of the PEARLS Deep Survey, sits in the Draco constellation, located at the right ascension position of 1722, 47.90, and declination position of plus 65, 49, 21.54. As we embark on this journey through space, the James Webb Space Telescope continues to unlock new knowledge and push the boundaries of what we thought was possible, enabling us to comprehend our cosmos in more profound ways. It not only stokes our curiosity, but answers age-old questions about our place in the universe. Indeed, it is a remarkable time for cosmic exploration. Number 3. A new benchmark: NASA's Webb's ongoing voyage to the earliest galaxies. NASA's James Webb Space Telescope, an epitome of international collaboration, is writing new chapters in our knowledge of the cosmos. Its cutting-edge technology has led to a milestone discovery of the oldest confirmed galaxies ever detected, hailing from an era less than 400 million years post-Big Bang. This period represents only 2% of the universe's current age, an early infancy in cosmic terms. Just imagine, the light from these galaxies has journeyed over 13.4 billion years before being captured by Webb's state-of-the-art detectors. Now, that's an intergalactic voyage that might make even the most seasoned science fiction fans pause in wonder. But how can we be sure these galaxies are truly so ancient? Astronomers had earlier identified potential candidates for these youthful galaxies using Webb's initial data. The crucial next step was confirmation, accomplished through meticulous spectroscopic observations. Spectroscopy involves analyzing the fingerprints of light from celestial objects to reveal distinctive patterns unique to each galaxy. And these galaxies were no exception. Think of it like a cosmic version of a detective story, where the investigators are astronomers like co-author Emma Curtis Lake from the University of Hertfordshire, UK. Curtis Lake reminds us of an interesting cosmic plot twist. It's not uncommon for closer galaxies to impersonate distant ones. Hence, the confirmation of these galaxies being at the edge of our observable universe, a zone beyond even Hubble's reach, is an exhilarating accomplishment for the Webb mission. The discovery was made possible through the combined efforts of scientists involved in the development of Webb's near-infrared camera, NIRCam, and the near-infrared spectrograph, NIRSpec. Back in 2015, these teams united to propose the ambitious JWST Advanced Deep Extragalactic Survey, JADES. Designed to deliver an unparalleled glimpse into the early universe's depth and detail, JADES is a testament to international cooperation, involving over 80 astronomers from 10 countries. Co-author Marcia Ricci, the principal investigator for NIRCam at the University of Arizona, notes that these findings are precisely why the NIRCam and NIRSpec teams collaborated on this immense project. The inaugural series of JADES observations focused on the vicinity of the Hubble Space Telescope's ultra-deep field. This relatively small celestial patch has been the go-to for nearly all large telescopes for over 2 decades, leading to an extremely sensitive data set encompassing the full electromagnetic spectrum. Now, Webb adds its unique viewpoint, offering the most detailed and faintest images yet achieved. The NIRCam was first up, spending over 10 days to observe the field in 9 different infrared colors, producing breathtaking images of the sky. Despite the field being only about the size of a human seen from a mile away, it's bursting with nearly 100,000 galaxies. Each of these galaxies is captured at a specific moment in their history, billions of years in the past. Through these images, the early universe's galaxies exhibit telltale, multi-wavelength colors. As the universe expands, the light from these galaxies is stretched, increasing its wavelength. In the case of these youngest galaxies, this stretching is by a factor of up to 14. The JADES team painstakingly examined the Webb images for these specific spectral signatures. To further study these galaxies, the NIRSpec instrument was used to observe the light from 250 faint galaxies over a continuous 3-day observation period. The gathered data allowed astronomers to examine patterns left on the light spectrum by atoms within each galaxy, leading to precise redshift measurements and insights into the properties of the gas and stars within these galaxies. Among the galaxies studied, 4 were revealed to be truly special, residing at an epoch previously unexplored. The resulting spectroscopic confirmation placed these 4 galaxies at redshifts above 10, including 2 at redshift 13. This period corresponds to when the universe was a mere 330 million years old, pushing the frontier in the search for distant galaxies to new limits. According to Sandro Tacella, a co-author from the University of Cambridge, UK, understanding galaxies' early developmental stages is pivotal for unraveling their later complexities. It's like the galaxy's childhood, where early generations of stars significantly influence the galaxy's future. As we continue to harness the transformative potential of the Webb telescope, the mysteries of these galaxies will unfold. The quest continues in 2023, when JWST embarks on a detailed study of another field, centered on the renowned Hubble Deep Field, before returning to the ultra-deep field for another round of in-depth imaging and spectroscopy. As the journey continues, more candidates in the field await spectroscopic investigation, setting the stage for new and exciting discoveries in the cosmos. Image 4. The first direct glimpse of a cosmic giant. Exoplanet HIP, 65,426b in near and mid-infrared. An unprecedented glimpse into the celestial deep has been granted, courtesy of NASA's James Webb Space Telescope. It has provided us with the first direct image of an exoplanet, a term used for planets outside our solar system. This gas giant, much like Jupiter, has no solid surface for life as we know it to inhabit. What exactly is a gas giant? Imagine a planet composed mostly of gases, such as hydrogen and helium, with possibly a core made of heavier elements. It's like a celestial balloon, not a solid rocky body like Earth. Fascinating, isn't it? Through the prism of 4 distinct light filters, Webb's potent infrared eyes effectively capture realms beyond our own solar system. This ability promises to uncover unprecedented details about these far-off planets or exoplanets in the future. Sasha Hinckley, Associate Professor of Physics and Astronomy at the University of Exeter and leader of a broad international collaboration, recognized this as a significant milestone. Not only does it amplify Webb's capabilities, but it also ushers in a new era for the world of astronomy. Keep in mind that Webb is a collaborative mission helmed by NASA, with the European Space Agency, ESA, and the Canadian Space Agency, CSA, as partners. This cosmic gas balloon captured in Webb's image is known as HIP 65426b. It is 6 to 12 times the mass of Jupiter, and the data from these observations could help narrow down this range even further. This planet is a cosmic youth, aged about 15 to 20 million years, while our own Earth is a venerable 4.5 billion years old. The discovery of HIP 65426b dates back to 2017, thanks to the SPHERE instrument on the European Southern Observatory's Very Large Telescope in Chile. The images were taken using short infrared wavelengths of light. Webb's image, captured in mid-infrared light, provides a glimpse of the unseen, details that terrestrial telescopes cannot perceive due to Earth's own atmospheric infrared glow. Researchers have been scrutinizing the data from these observations and are on the brink of submitting a paper for peer review. However, Webb's initial capture of an exoplanet already points towards exciting opportunities for studying these distant worlds. HIP 65426b orbits its host star at a distance about 100 times farther than Earth's orbit from the Sun. This immense gap enables Webb to distinctly differentiate between the planet and its star in the image. Equipped with coronagraphs, tiny masks that filter out starlight, both of Webb's near-infrared camera and mid-infrared instrument are capable of capturing direct images of certain exoplanets, including HIP 65426b. Intriguingly, NASA's upcoming Nancy Grace Roman Space Telescope promises an even more advanced coronagraph. The process of capturing direct images of exoplanets is a daunting task due to the overpowering brightness of their host stars. To give some perspective, HIP 65426b is more than 10,000 times fainter than its host star in near-infrared and a few thousand times fainter in the mid-infrared. Upon closer observation, one would notice that the planet appears as a slightly differently shaped blob of light in each filter image. Why is this the case? It's due to the unique characteristics of Webb's optical system and the different ways it guides light through its optics. Erin Carter, a postdoctoral researcher at the University of California, Santa Cruz, likened the process of obtaining this image to a quest for cosmic treasure. Initially, only the light from the star was visible, but with meticulous image processing, she managed to isolate the light from the planet. While the Hubble Space Telescope has previously provided us with direct exoplanet images from space, the image of HIP 65426b demonstrates Webb's potential in further exoplanet exploration. Chip 65426b resides in the Centaurus constellation, approximately 385 light-years away from us. As Carter states, this is just the beginning. Future images of exoplanets promise to enrich our understanding of their physics, chemistry, and formation. We might even stumble upon new, hitherto unknown planets. The universe is a vast and grand stage, with each discovery opening a new act in our cosmic play. As our understanding deepens with each direct glimpse into these distant worlds, we draw one step closer to answering profound questions about our place in the cosmos. Image number 5. Webb's spectacular debut, the deep field exploration using NIRSpec's microshutter array. NASA's Webb telescope hosts an intriguing instrument on board, the Near-Infrared Spectrograph's microshutter array, a modern marvel of miniature engineering. This array contains over 248,000 miniature doors, each of which can be individually operated to collect spectra, the array of colors or wavelengths of light, from as many as 150 individual celestial bodies at the same time. So what's a spectrum? Think of it as a fingerprint of light, each color representing a different wavelength. By studying these wavelengths, astronomers can learn a lot about the source of the light. In the constellation of Volans, the flying fish, thousands of galaxies shimmer in the background of the galaxy cluster SMACS 0723. In one swoop, NIRSpec managed to observe 48 of these galaxies in a field the size of a grain of sand held at arm's length. From a quick look at the collected data, several galaxies were observed as they were billions of years ago in the universe's timeline. And remember, the universe is approximately 13.8 billion years old. Now, take a closer look at the spectra. Can you spot a pattern? There's a sequence of 3 lines that appear consistently. One line from hydrogen, followed by 2 from ionized oxygen. These lines help astronomers pinpoint the redshift of individual galaxies. But what does redshift mean? Redshift is an effect that makes the light from objects moving away from us appear more red, and it can tell us how far away and how long ago these galaxies emitted their light. In fact, the light from the most distant galaxy Webb captured on this instance has been on a long, lonely voyage, traveling 13.1 billion years before finally reaching Webb's mirrors. This observation is historical. It's the first time these specific emission lines have been detected from such far-off galaxies. But hold on to your hats, because this is only the beginning. There could be even more remote galaxies hiding in this image. Webb's spectra reveal more than just distance. For the first time, we're peering into the chemical makeup of galaxies from the early universe. Webb's position in space, far away from Earth's atmosphere that absorbs some infrared light, and its specialization in gathering high-resolution near-infrared light, allow us to take this deep look back in time. Astronomers are no strangers to studying spectra from galaxies closer to home, thanks to various space and ground-based observatories. But now, the arrival of Webb's data allows us to compare these spectra from vastly different times in the universe's history. This means we can begin to chart how galaxies have evolved over billions of years, right back to the universe's youth. Armed with the wealth of information Webb's data provides, researchers can measure a galaxy's distance, temperature, gas density, and chemical composition. We're on the brink of a knowledge explosion about galaxies spanning across cosmic history. Are you feeling a bit of celestial wanderlust? Why not try your hand at gathering your own spectra with Webb's microshutter array? Learn how scientists operate the instrument and examine the spectra it yields with an interactive tool. We may not all be able to journey into space, but that doesn't mean we can't explore the universe from the comfort of our homes. Number 6. Dancing in the Cosmic Sea, the Tale of a Jellyfish Galaxy and Ram Pressure. This tale begins with JWST 204, a celestial object known as a jellyfish galaxy, a name inspired by its vibrant gas tendrils, which resemble the languid drift of a jellyfish's tentacles in the sea. Captured in this spectacular image by the Webb telescope, JWST 204, located nearly 600 million light-years away in the Sextans constellation, appears to dance with ethereal beauty in the cosmic ocean. Isn't it fascinating to observe an object so far away in a corner of the universe that we've never physically explored? This image is a part of a series resulting from a survey that studied 6 such mesmerizing galaxies, including JO-204. The purpose? To gain a better grasp of how stars come into existence under extreme circumstances. You might be wondering, what could possibly link these tranquil jellyfish galaxies to violent star formation? As we've often found in astronomy, initial appearances can mask a more complex reality. Although the wispy ribbons of gas beneath JO-204 seem as peaceful as a jellyfish's undulating tendrils, they are, in fact, products of a powerful astronomical phenomenon known as ram pressure stripping. At this point, you may ask, what exactly is ram pressure? Well, consider standing in a strong gust of wind. The pressure you feel against your body is ram pressure, exerted as your body moves relative to the fluid, in this case, air. Despite the wind's force, your body remains intact while loosely bound elements, such as your clothes or hair, ripple in response. This wind is analogous to the intergalactic medium, the air that exists between galaxies in a cluster. Now let's take this analogy to the cosmos. As jellyfish galaxies like JO-204 move through the intergalactic medium, they encounter ram pressure. This causes their loosely bound gas to be stripped away, similar to how your hair flutters in the wind. This stripped gas is typically the colder, denser gas of the galaxy. As it encounters the ram pressure, it collapses and compresses, giving birth to new stars within the splendid tendrils of the jellyfish. Remember the galaxy JO-204, which also goes by another name, ZWCL 1012-0047. It's a fascinating place teeming with star birth, brought about by forces we can compare to our everyday experiences, even if it happens on a cosmic scale. So, the next time you feel a gust of wind against your face, imagine what a galaxy far away in the constellation Sextans might be experiencing. Isn't it thrilling how our everyday experiences can connect us to the farthest reaches of our universe? Number 7. The Cosmic Neighborhood, an intimate look at UGCA 307. In the expansive cosmic theater, the Webb Space Telescope presents us with an intriguing act, UGCA 307. Amidst a cosmic mosaic of distant galaxies, this small dwarf galaxy holds its own with a sparse scattering of stars and striking bubbles of red gas, clear indicators of ongoing star creation. Nestled roughly 26 million light-years away in the Corvus constellation, it might seem like a nondescript gathering of stars, akin to a wandering cloud in our earthly skies. Isn't it captivating to think of such a galaxy, so distant yet intricately detailed? The image of UGCA 307 is part of a broad project by the James Webb Space Telescope, designed to probe every identifiable galaxy in our cosmic vicinity. Until this ambitious project, Webb had scrutinized almost 3/4 of the nearby galaxies, enough to identify the brightest stars and acquire a solid understanding of their stellar compositions. Now, filling in the short gaps in Webb's observation schedule, the project is set to explore the remaining quarter of our nearby galactic neighbors. Would you believe that UGCA 307, located in the Corvus constellation, is over 36 million light-years away from us? Although not a part of the well-known Messier catalog, UGCA 307 is a distinct galaxy, not linked to our Milky Way galaxy or our solar system. Can you imagine what might be going on in UGCA 307? Perhaps it hosts exoplanets in its many star systems, potentially teeming with life forms alien to us. Yet our current technology binds us to Earth. A visit to UGCA 307 remains a distant dream, unless we learn to create wormholes to shorten our cosmic travels. Isn't it incredible to think that when we gaze upon UGCA 307, we are peering millions of years into the past? Light from this galaxy started its journey to us even before the dinosaurs faced extinction 65 million years ago. However, please note that the distances we've calculated for UGCA 307 are approximations, based on current observations and calculations. Even at a rough estimate of over 36 million light-years, the journey to UGCA 307 gives us plenty to ponder. The voyage duration would entirely depend on the speed of our travel. For instance, let's take the New Horizons space probe, the fastest we've ever sent into space. If you recall, its initial mission was to explore Pluto, which was classified as a planet when the probe was launched in 2006. If we were to travel at that speed, it would take over 736 billion years to reach UGC 307. But what about other modes of transportation? How about a walk? If we could stroll through space at a comfortable 4 mph, we'd arrive in a staggering 6 quadrillion years. With a car traveling at 120 mph, it would still take over 202 trillion years. Even at the speed of sound, also known as Mach 1, we're looking at around 31 trillion years. Doubling the speed to Mach 2, the speed of the Concorde, the journey would still take nearly 16 trillion years. And remember, when we talk about these years, we're referring to non-leap years, each 365 days long. Isn't it astounding how immense the universe is? That even at the speed of light, the journey to UGC 307 would take over 36 million years? Yet, through the lens of the Webb Space Telescope, we get to see these distant galaxies up close, each one a treasure trove of cosmic knowledge waiting to be explored. What other mysteries will our cosmic neighborhood watch reveal? Number 8. The cosmic dance of a trillion stars, a peek into the spiral galaxy. Messier 98. Our story today takes us on a journey to Messier 98, an enchanting spiral galaxy situated about 45 million light-years away in the constellation Coma Berenices, also known as Berenice's Hair. Discovered in 1781 by French astronomer Pierre Méchain, Messier 98 is indeed an otherworldly spectacle. Despite being one of the least luminous objects in Charles Messier's famed astronomical catalogue. Could you imagine a place so rich with stars that it houses an estimated trillion of them? That's precisely what Messier 98 offers us. Nestled within this galaxy is a plethora of cosmic dust, displayed as a tapestry of red-brown across the expanse of space. This galaxy is not just a static picture, though. It's a bustling cosmic city, teeming with hydrogen gas, the building blocks of stars. Now, why is hydrogen gas so essential? It's because this element is vital for star creation. And with such a wealth of it, Messier 98 is a veritable nursery for newborn stars. Signs of this lively birth process are evident in its vibrant center and swirling arms. The story gets even more fascinating when you delve into the specifics. Messier 98, also known as M98 or NGC 4192, lies in slightly northerly Coma Berenices, around 6 degrees east of the radiant star Denebula, Beta Leonis. It appears to be approaching us, moving closer at about 140 kilometers per s when discounting other vectors of motion. This approaching movement is known as a blue shift in astronomical parlance. Interested in the structure of galaxies, Messier 98 is an SABS-AB type, indicating it's a spiral galaxy with a blend of barred and non-barred features. Its arms are intermediate to tightly coiled, like a cosmic ball of yarn, but without a ring. Viewing this galaxy is a bit challenging since it is inclined to our line of sight at a steep angle of 74 degrees. Weighing the equivalent of an estimated 76 billion suns, Messier 98 is incredibly massive. It also contains about 4.3 billion solar masses of neutral hydrogen and 85 million solar masses of dust. Its nucleus or center is active, exhibiting traits of a transition-type object, which means it shows characteristics of a low-ionization nuclear emission line region, LINER-type galaxy, intermixed with an H2 region around the nucleus. In simple terms, it's a bustling hub of activity and star formation. Not to forget, Messier 98 is part of the Virgo cluster, a grand gathering of galaxies that belong to our local supercluster. Messier 98 is more than a distant galaxy. It's a vibrant star-forming machine, a member of a vast cosmic community, and a testament to the wonders of the universe. Isn't it humbling to consider our place in this expansive cosmic dance? Number 9. The Spiral Dance of NGC 1433, a tale of a luminous galactic heart. Imagine peering into the distant cosmos, witnessing galaxies that exist millions of light-years away. One such fascinating spectacle is the nearby spiral galaxy, NGC 1433, located approximately 32 million light-years from our home, the Earth. This image, taken by the Webb Space Telescope, introduces us to the mesmerizing vista of a Seyfert galaxy, a unique class of galaxies that represent 10% of all known galaxies. Intriguingly, these galaxies possess brilliantly glowing centers that rival the luminosity of our own Milky Way. Have you ever wondered what lies at the heart of these galactic titans? Well, astronomers believe that the core of most, if not all, galaxies harbor a supermassive black hole. This black hole is not isolated, but rather is encircled by a disk of material spiraling inward, much like water circling a drain. NGC 1433, nestled within the Horologium constellation, is currently under scientific scrutiny as part of a survey of 50 neighboring galaxies. This investigation, known as the Legacy Extragalactic UV Survey, LEGIS, is dedicated to observing ultraviolet radiation emitted by these galaxies. The ultraviolet light acts as a spotlight, highlighting the most recently formed stars. Interestingly, in Seyfert galaxies like NGC 1433, ultraviolet illumination is also believed to stem from the accretion disks enveloping their central black holes. Doesn't it make you wonder about the energetic dances that occur near these cosmic behemoths? A fascinating exploration of these galaxies using the ultraviolet spectrum can reveal vital clues about the behavior of the gas near the black hole. This image of NGC 1433 has been stitched together using ultraviolet, visible, and infrared light, offering a glimpse into its mysterious core. The LEGIS investigation aims to unveil the wide spectrum of properties intrinsic to these galaxies, such as their internal structure. This Hubble survey will lay the groundwork for future observations with state-of-the-art telescopes like the James Webb Space Telescope and the Atacama Large Millimeter Submillimeter Array, ALMA. In fact, ALMA has already gifted us with unexpected findings from the heart of NGC 1433. A surprising spiral structure was discovered in the molecular gas near the galactic center. Even more intriguing, a jet of material was observed flowing away from the black hole, extending a mere 150 light-years, marking the shortest molecular outflow ever observed in a galaxy beyond our own. Isn't it fascinating how the distant cosmos, with galaxies like NGC 1433, offer a glimpse into the vibrant processes occurring millions of light-years away? As we continue to explore these galaxies, we become more connected to the immense cosmic dance that unfolds beyond our earthly home. Image number 10. Gazing across the light-years, the tail of NGC 1073. Picture this. You're viewing an extraordinary snapshot, one that transcends the boundaries of time and space, capturing the grandeur of a celestial object located tens of millions of light-years away. This is what the Webb telescope has accomplished with its latest image, depicting the captivating barred spiral galaxy known as NGC 1073. Nestled within the constellation of Cetus, aptly named the Sea Monster, this galaxy invites us to explore the unknown and make profound connections between us and the cosmos. But what exactly does barred spiral galaxy mean? In simple terms, it refers to a galaxy with a bar-shaped structure composed of stars, extending from its center and wrapping around in a spiral formation. Sounds familiar? That's because our home, the Milky Way, is considered a barred spiral too. By studying galaxies like NGC 1073, astronomers gain precious insights into understanding our own celestial dwelling. NGC 1073 is an intriguing entity, situated roughly 55 million light-years from Earth. To give you an idea of just how vast that is, consider this. If we could travel at the speed of light, it would take us 55 million years to reach it. That's around 400 times the age of our own species, Homo sapiens. The galaxy spreads out majestically over a span of 80,000 light-years in diameter, making it about 4/5 the size of the Milky Way. Another interesting aspect of NGC 1073 is its nucleus, believed to be an H2 nucleus. This term denotes an active core comprising large amounts of ionized atomic hydrogen, a hotbed for new star formation. Although both the Milky Way and NGC 1073 share the characteristic of a galactic bar, there are fascinating differences. NGC 1073 does not flaunt the symmetrical arm structure that our Milky Way so proudly exhibits. and it possesses a central bar larger than our home galaxies. These variations are testament to the immense diversity that exists even among galaxies that share a common structure. With the right equipment, such as a mid-sized telescope under clear rural skies, you could potentially observe NGC 1073. Imagine standing under the stars, peering through the telescope and catching a glimpse of a galaxy 55 million light-years away. NGC 1073 has also been the stage for an extraordinary cosmic event, the occurrence of a supernova designated SN 1962L. A supernova is a dramatic explosion that signifies the end of a star's life cycle, an event that can briefly outshine an entire galaxy. Known by several other names, including IX05, J024333, 6 plus 0 12222, PKS 0241 plus 011, QSO B0240 plus 011, and VV96, that's a mouthful. This galaxy continues to unravel its secrets to us, one observation at a time. Isn't it incredible that we can learn so much about our own galaxy by studying the distant cosmos? Truly, the universe is a treasure trove of knowledge, waiting for us to uncover its mysteries. Number 11. Cosmic Pageantry, the intricate dance of the Cigar Galaxy. Nestled within the constellation Ursa Major, around 13 million light-years away from us, resides a truly extraordinary galaxy, Messier 82, or, as it's more fondly known, the Cigar Galaxy. This bustling cosmic metropolis stands as the second largest member of the M81 group, stretching an astonishing 40,800 light-years across its D25 isophotal diameter. What makes M82 such a sight to behold? It emanates light with a luminosity 5 times greater than our own Milky Way. Imagine the breathtaking spectacle it would be if our night sky were lit up by such a luminary. But the spectacle doesn't end there. The core of this galaxy is a blazing torch shining about 100 times more brightly than our galaxy. Why does M82, this beacon in the cosmos, shine so brightly? The explanation takes us to a cosmic drama between it and its neighboring galaxy, M81. These celestial bodies, in their immense gravity dance, triggered a process of intense star formation within M82, transforming it into one of the closest starburst galaxies to Earth. An intriguing subplot in this cosmic drama came to light on January 21, 2014, when astronomers discovered a Type Ia supernova, named SN 2014J, within M82. In the same year, scientists studying M82 identified the most radiant pulsar ever discovered, dubbed M82X2. The Cigar Galaxy was first spotted in 1774 by Johann Elert Bode, who described it as an elongated nebulous patch. This description, combined with its proximity to its sibling nebula, led to its rediscovery in 1779 by Pierre Méchain, who promptly reported them to Charles Messier, ensuring their place in his famed catalogue. Fast forward to April 2010, and the Cigar Galaxy was once again the center of intrigue. At the Jodrell Bank Observatory of the University of Manchester, UK, radio astronomers identified an object within M82 emitting unfamiliar radio waves, unlike anything seen in the universe before. What could this mysterious object be? The answer remains elusive, as it doesn't fit into any existing theories perfectly. Some scientists propose it could be a peculiar microquasar, known for high radio luminosity but low X-ray luminosity. However, all known microquasars produce substantial amounts of X-rays, while this object's X-ray flux lies beneath the threshold of detection. The object's location, a few arcseconds from M82's center, makes it an unlikely associate of a supermassive black hole. Intriguingly, it shows an apparent superluminal motion, moving at an apparent speed 4 times faster than light relative to the galaxy's center. Before we get too excited, though, this type of motion is consistent with relativistic jets in massive black holes, and it does not mean the source itself is exceeding the speed of light. The gravitational dance between M82 and its larger neighbor, M81, has caused significant changes in M82's physical structure. Over 100 million years ago, these changes instigated a dramatic increase in star formation, 10 times higher than typical galaxies. Historically, M82 has experienced at least one significant interaction with M81, channeling a large amount of gas into M82's core over the last 200 million years. This interaction caused an intense burst of star formation about 5x10 circumflex 8 years ago, leaving its mark in the cluster age distribution. This starburst may have given birth to the core clusters, forming both superstar clusters and their lighter counterparts. This galaxy has a rich history of star formation. Stars in M82's disk appear to have been created in a burst around 500 million years ago. This event scattered hundreds of clusters, akin to young globular clusters, across the disk. However, star formation ceased about 100 million years ago, leaving the galaxy with no new stars outside the central starburst and some minor activity in its halo dating back 1 billion years. So how far apart are M81 and M82 truly? When viewing from Earth, the centers of M81 and M82 appear to be separated by about 130,000 light-years. However, their actual separation is around 300,000 light-years, give or take. Isn't it incredible how much activity and history can be found within a single galaxy, like the Cigar Galaxy and its cosmic neighborhood? These tales of gravitational dances, starburst galaxies, and peculiar radio signals remind us of the awe and mystery that await us in the far reaches of space. Number 12. The Cosmic Carousel, NGC 986's spiral dance in the celestial furnace. Welcome to the realm of NGC 986, a majestic galaxy poised in the constellation of Fornax, also poetically known as the Furnace. This celestial marvel, residing around 55 million light-years away from us, dazzles observers with its sun-drenched core and the hypnotic swirl of its barred arms, beautifully captured in this vivid image. You might ask, what is a barred spiral galaxy? Simply put, it is a spiral galaxy that boasts a central bar-like structure composed entirely of stars. NGC 986 exhibits this galactic architecture, wearing an S-shaped structure that etches across the cosmos. Young, vibrant blue stars pepper the galaxy's arms, and its heart beats with the rhythm of ongoing star creation. What is peculiar about the top right of this image, you may wonder? The fuzzy appearance of the stars there is a consequence of merging data from the Webb Space Telescope and ground-based telescopes. Although the amalgamated patch paints an accurate cosmic picture, the ground telescope's resolution doesn't quite match Webb's crisp portrayal of the spiral galaxy. To deepen our understanding, let's journey back to the discovery of NGC 986 on August 5, 1826. It was the Scottish astronomer James Dunlop who first spotted this faint nebula of an irregular round figure. This barred spiral galaxy is a member of the Fornax cluster of galaxies and has an unconnected companion, NGC 986a, at an angular separation translating to a projected separation of 110 kiloparsecs. What's happening at the core of NGC 986? A stellar nursery thrives, fueled by intense star formation, creating what we call an H2 region, a glowing cloud of ionized hydrogen gas. The galaxy's central bar, extending approximately 14 kpc, is packed with dense gas. From either end of this bar emerge two broad, slightly curved arms, sketching out the galaxy's characteristic S-shape. Intriguingly, there may even be a dwarf galaxy, torn apart by tidal forces at the end of its northern arm. Isn't it astounding how a galaxy millions of light-years away can bring such splendor to our earthly gazes? The tale of NGC 986 serves as a reminder of the fascinating, beautiful complexity that graces the cosmos, dancing its spiral waltz in the grand celestial furnace. Number 13. A Cosmic Dance. The tale of the NGC 1512 galaxy and its neighbor. This captivating image paints a colorful tale of an intricate, distant celestial structure. Known as NGC 1512, this barred spiral galaxy presents a spectacle of cosmic beauty, roughly 40 million light-years from our home planet. Resting in the constellation Horologium, also known as the Clock, the galaxy's charm doesn't just lie in its intricate structure, but also in its intriguing dance with a nearby companion. But how did we get such a detailed image of something so distant? The process involved 7 unique exposures across a spectrum of light frequencies. The result? A vibrant multi-wavelength composite image that brings the cosmic complexities of NGC 1512 to life. NGC 1512, also recognized as IRAS 04022, 4329, boasts a striking double-ring structure. It has a nuclear ring closely hugging its galactic nucleus and an inner ring situated further out in its sprawling main disk. But what makes NGC 1512 particularly interesting? Have you ever seen the glow of newly formed stars? NGC 1512 is home to an extensive ultraviolet disk, hosting at least 200 clusters, teeming with the vibrant glow of fresh star creation, adding to the richness of this cosmic spectacle. This beautiful barred spiral is a proud member of the Dorado Group, a collection of galaxies that shares the southern sky with the Horologium constellation. But the story doesn't end with NGC 1512's breathtaking visual and inherent allure. This celestial titan is engaged in a slow cosmic dance with a nearby dwarf lenticular galaxy, NGC 1510. The galaxies, separated by a mere 13.8 kiloparsecs, or about 5 arcman in the sky, are locked in a merger that has been unfolding for an impressive 400 million years. Imagine a dance so lengthy, a show so prolonged, that its climax sees one partner absorbing the other. This is the fate of NGC 1510 as it moves towards an inevitable cosmic cannibalization by its larger neighbor, NGC 1512. As you marvel at this, consider the ripple effect of this grand interaction. The gravitational tidal forces set off by this merger stir up star formation activity in NGC 1512's peripheral disk and intensify the tidal distortion in the galaxy's arms. The epicenter of this interaction appears to be the northwestern regions of NGC 1512, as evidenced by the broadening of its hydrogen HI arm and the dispersal of UV-rich star clusters in this area. In the end, the interaction of these galaxies, set in the clock face constellation, underscores the dynamic nature of our universe. Every image we capture, such as this one of NGC 1512, reveals a story of creation, transformation, and evolution, each a single beat in the rhythm of the cosmos. Image number 14, The Grand Deception, an encounter with the quintuple vision in the cosmos. In the heart of the Virgo constellation, captured in this mesmerizing image, a curious light spectacle unfolds. You may see 6 radiant spots of light, 4 of which are seemingly arranged in a ring around a central duo. This fascinating tableau of cosmic illumination, however, holds a surprising truth. What appears as 6 entities are actually just 3, a pair of galaxies and 1 far-off quasar. Data from the Webb telescope even suggests a faint 7th spot at the very center, which adds another layer of mystery, a rare 5th image of the remote quasar. This unusual event occurs due to the presence of the 2 foreground galaxies behaving as a cosmic lens. The duo at the center of this image are indeed 2 distinct galaxies. But what about the other lights? The 4 brilliant points encircling them and the dimmer spot nestled at the center are not separate entities. Rather, they are 5 distinct reflections of a single, very bright but far-off quasar known as 2M1310-1714. This cosmic illusion, leading to our seeing quintuple, is caused by a space phenomenon known as gravitational lensing. But what exactly is gravitational lensing? Imagine a stone thrown into a pond. The stone, like a galaxy, creates ripples or a warp in the water, which represents the fabric of space. Now picture a leaf, light from a distant object, floating on these ripples, its path changing direction following the water's curvature. This is how gravitational lensing works in space. Celestial bodies with colossal mass, like galaxies, can distort the fabric of space so much that light traveling through it bends and magnifies, allowing us here on Earth to see multiple enlarged images of the far-off source. In our case, the quasar, 2M1310-1714, lies even further from Earth than the galaxy duo does. As the light from the quasar journeys toward us, it bends around the immense mass of the galaxy pair, creating the illusion that the two galaxies are encircled by four separate quasars. Yet in reality, a single, distant quasar lies far behind them. So the next time you gaze at the stars, remember this cosmic illusion where a solitary quasar disguises itself as multiple entities, demonstrating the enchanting and sometimes deceptive beauty of our universe. How many more of these optical illusions do you think the cosmos might be hiding? We're left in awe of the myriad celestial wonders that exist far beyond our earthly gaze. Each image, a testament to the intricacies of the universe we inhabit, offers us a new story of cosmic evolution and stirs our thirst for knowledge. If you found this journey as mesmerizing as we have, don't forget to express your appreciation by liking this presentation. Stay connected to our future explorations by hitting the subscribe button. Every click brings you a step closer to unraveling more cosmic mysteries and brings us the joy of sharing these celestial marvels with you. For those yearning for another space adventure right now, there's a video on your screen ready to take you on another stunning exploration of the universe. Don't hesitate, click and embark on your next interstellar journey.